Okay, as usual, very quick announcement. Okay, Lab 1, it is due this Friday, 3 p.m. Okay, 3 p.m. Right. There will be some TA's office hour. It's in the Sun 2056 from 12 to 2 p.m. But it kind of clashes with your scheduled lab. So I would say either stay in the lab or go to the office. Either way is fine. Okay, just get some help if you need it. And my office hour the same today, 3 to 5. Just in case you need some last minute help, feel free to come by tomorrow. Extra 3:30 to 5:30 if that helps. Okay. I cannot make it to Friday's lab just for this week, so that's why I'm holding some extra hours. So if you need help, just come by. Or if you want to ask me some general course-related question, you can also come by. That's not a problem. Okay. Okay, so the topic for today, we want to finish about writing complete postconditions, right? I believe you have to write a little bit postcondition for your lab 1. Hopefully after today, you'll get more insight. Specifically, how you can use the O keyword and how to, in combination of twin, deep twin, or reference copy. Now today, we're going to discuss that in details. Okay, let me just bring you up to speed very quickly. Just review, just take a few minutes. So in general, for your particular feature, it can be a query, it can be a command. You got some precondition here. Precondition is pretty easy to check. As soon as you get to the pre-state, you just check them to see if that's true or not. The trouble really is about the postcondition. And trouble is, after you have done the body of the implementation over here, you have already overwritten the values for the attributes in the pre-states. So you want to make sure when you say O expression over here, you can really compare the true value you really want to compare. That's kind of the issue we're going to talk about. So the way I'm going to do it today, I will give you, first of all, a variety of possibility of writing O expression and talk about the consequences for each. And then we'll do a complete example with various versions to see how we can ultimately get to the final version. That's the plan for today. And then next week, we'll talk about math models. Okay, that's kind of the plan. Okay, just to remind you very quickly, and then we'll talk about the details. Every time when you call a particular feature, you definitely have to check the precondition. Okay, so again, this is called a pre-state, right? We'll talk about it on Monday. And then, while you're after checking the precondition, let's say it is satisfied, so now we have to execute the implementation by the supplier. In that case, we have to make sure in order for us to properly execute or to check the postcondition later, you have to somehow cache or to store properly the O expression so you can use them later in the post states. That's really the key. And the advantage of using Ifill as a design language is you don't have to cache these values yourself, but you have to understand how they are being done automatically. So you will know how to write the O expressions accordingly. Okay? Okay, then this is the post states. Okay, that's basically what we talked about last time. Okay, before I continue with a variety of O expressions, do you have any confusion between the pre-state and post states? As long as you're clear about these two notions, you should be ready to talk about the next discussion. Okay, in the slides, as I show you from Monday, I show you a list of possible O expressions. The best way to really illustrate them is to use some concrete example. Okay. Let me just show you how you can understand what I have set up, and then we'll talk about it. Hopefully we can go through every one of them, but we'll just go through just enough so you can do it on your own as well. Let's say the following. Let's say now we are in the context of some ensure postcondition. And then in the ensure postcondition, we might write 7 possible postconditions over there using the O keyword in combination of either reference copy, shallow copy, or deep copy, right? Different combinations. And let's say our particular runtime structure to consider is we have a single bank, and the bank has simply an array of accounts. Each element in the account, for example, in element I, let's say I is a valid index, is simply pointing to some account objects. For every account, you have an integer ID 23, for example. Okay, that's kind of our easy setup. Okay, let's say that's how we start with. Now we want to know, depending on what you write in the ensure clause, from number 1 to number 7, what would be the caching process for Ifill runtime in the pre-state, right? We talk about you should really cache the value for all expressions in the pre-states so you can check it properly in the post-states. Okay, let's talk about each one of them. Okay. The easiest way to think about is, first of all, think about which expression specifically is being applied to the O expression, the O keyword. For example, what do I mean by that? If you look at this particular, let's say number 1 over here, find the longest unbreakable expression after the O keyword. Okay? In this case, you can see that after the O keyword here, you can see its accounts, it's not breakable just yet. So I got to go on to index I. Not breakable just yet. So I got to go all the way to ID. Okay? So that means when I actually write this particular post condition, this entire expression is going to be stored in the pre-states in order for me to compare later in the post states. Okay? Any questions until now? But we're going to see different examples so you get a feel. Yes, question?
So what does the index I?
Index I, you can think about just something in the context. Let's say, okay, think about what this really means.
If you had a variable right above it that was called I.
Yeah, something like that. I just didn't specify I here, but you can assume that I is something that's valid. Okay? So now, over here. In the post condition, if I say O keyword, and then I say accounts the array at position I dot ID. Okay? Hey, Jordan.
So that means you, like, depending on how you were using I in your post condition, that means all of the accounts have been cached, like all of the account IDs have been.
Oh, okay. So let's say for number 1, let's say that's the only O expression in your post condition.
Yeah.
So now we want to see what's the consequence of caching that in the pre-states. Okay, here's a question for you. Okay, only look at number 1. I want you to focus, right? Just number 1 here. Only look at this guy here. Okay, don't worry about number 2 to number 7 just yet. For number 1 here, we want to know what's the consequence of caching this particular value. Should we cache maybe the bank? Should we cache the array? Should we cache the account? Or should we cache the integer? You can see there are different levels of caching you can do. Which one to do? It depends on you as a developer how to specify the post condition. Okay? For this example specifically, what's the type for this particular unbreakable expression after the O keyword? Integer? Okay? Basically, we're referring to the ID, right? So that should be integer. So that means what Ifill runtime will do in the pre-states before they execute the body of the implementation. I'll try to be consistent with the color when I write it, okay? So now number 1 over here is simply just going to copy 23. That's it. So it's an easy one to, it's a cheap one to actually execute. Just cache the value for 1. That's example number 1. We're going to go over others. Let's look at number 2 to see some comparison. And now I want you to be very careful about number 2. Okay, I'll make it bigger for you. The key really is about the parentheses. Okay, so now this is the O keyword. What is now the longest unbreakable expression that should be applied by the O keyword? Basically, now it should be just account I, because the parenthesis over there forces the order of evaluation. It tells you stop here before you can call the ID. Okay? So now in this case, the O keyword here applies to just this particular expression. So now compare 1 and 2. What's the difference? The difference really is just about the parenthesis, right? For number 2, you got a parenthesis over here. That means O keyword only applies up to here within this particular parenthesis. On the other hand, for number 1, O keyword applies to everything after the O keyword here. Right? That's a difference. Okay. Having understood this, so now we want to know for number 2, how exactly are we going to cache? Okay. As I said last time, the way Ifill will do it is like this. Imagine that there might be some hidden variable just called number 2, for example, right? And now the way they cache that in the pre-state is say number 2 is simply assigned to whatever expression that should be cached verbatim. So now the expression should be accounts I. Just that. Now, is that a reference copy, shallow copy, or deep copy? Reference copy, right? So now, how should we draw number 2? We are doing a reference copy of the account, the array, or the bank? The accounts, would you agree? Because now accounts is an array of accounts, and then we go to some valid position I. So what we're doing now is number 2, if I try to draw it over here, number 2 should now be just pointing to this particular account. Okay? You can see from number 1 and number 2, the consequence of caching the pre-state value is different. Okay? Again, after the O keyword, whatever expression you write, you got to take the consequence. That's why you got to be careful. Let's do the next one. Number 3. Okay? Again, we got some contrast over here. Number 3 over here, again, after the O keyword, since we got a parenthesis, so the longest unbreakable expression will be only this part here. Agree? Okay, so now I want you to contrast 1, 2, and 3. So now what's the difference between 2 and 3? Do you think they might trigger the kind of the same backup process? It's a shallow copy, right? So you can see between number 2 and number 3, true, they both got parentheses around. But now, the way we cache number 3 is this expression has to be cached, has to be stored. So let's see exactly this procedure, okay? For number 3 over here, let's say there's a hidden variable called number 3. And then it's going to be assigned to whatever expression it is verbatim. So it would be accounts I dot twin. So it's a slightly more expensive caching, slightly different. Okay, let me draw the diagram and they'll take a question. Okay, so now how do we draw that? Okay, number 3 now should be pointing to some new array objects. Agree? Oh, should it be a new array or should it be a new account? New account, right? So what I'm drawing is wrong. Okay, be careful. Let's be careful. So now what you should realize is the type. So this by here is an account. Okay, just make a note. So what I would do now is I'm simply just going to say number 3 is now pointing to a new account object over here. And then it has an ID, in this case, just primitive type, just 23. Okay, that's number 3. Okay, give me some feel. Okay. The purpose of this slide here is just to give you a variety of choices before we see a complete example. So now, once you go back to Lab 1 and Lab 2 and future projects, you have to determine which one to use. Okay, I'll take questions first. You first.
Okay, so for the first one, I've used that cross loop before. It's giving an error that the I is on.
Aha, hold that thought over here. I do have one slide at the end. Okay, basically the question was about some very common compilation error, which I'll talk about. Okay, yes, question. Yeah. Good question. So now your question was really about, okay, first of all, when we do this particular shallow copy over here, you will agree we create a new account objects, okay? And then this guy over here for the attributes, it would be simply something like this. Think it this way. I'll write it a little bit more detail. Number 3 dot ID is simply assigned to, that's the definition for shallow copy. It's simply assigned to number 2. Oh, sorry, not number 2. It will simply be assigned to accounts I dot ID. So it's more like an integer copy. So copying primitive, just copy the value directly over. There's no address for primitive type. On the other hand, just hypothetically, imagine this. If, for some reason, we got this particular attribute pointing to some object, for example, hypothetically. In that case, how do you do a shallow copy? After you have created this particular shallow copy here, this attribute will just point to the same objects. That's a shallow copy, right? But now in this case, we got primitive, so we don't have to do it. Okay, yeah. Okay, let me just wipe this out so we can make more space. Okay, any more questions before I go on to the next one? Yes? Apparently, you can see over here, the question was, what's the type for the ID? Okay, accounts over here is of type array of account objects. And then if you say accounts at position I, it's of type accounts. And then if you say accounts at position I.ID, so it's basically integer. Yes. Yeah, so. No. Okay, let me make it more clear, unless you're, if you're really confused. Imagine that what we are trying to do. We say we are now in the context of the class called bank. And then over there we have an attribute, let's say accounts, which is an array of accounts. Okay, that's what we have. And then we basically got another class over here called accounts. Okay, the account class over here. And then we have basically one attribute here called ID of type integer. That's kind of the setup. I didn't really say precisely, right? So now, if you consider accounts versus accounts at position I versus accounts at position I dot ID in the context of this particular class, let's say, they're of different types, of course, right? This guy here, what's the type? Array of account. And this one here, what's the type? Account. And then this one here, what's the type? Integer. Right? It's some idea about association that's so common in OOP you have to be comfortable with. If you're not, maybe you want to talk to me after class. Okay, question?
So if you just go back to this slide.
Yes.
Hold on.
Yeah.
For number 3, is the ID actually is that its own little object, or is it supposed to point back to the
Oh, in this case, okay. Again, ID in this particular case, right? ID is of type integer. So when you do the shallow copy, you simply assign the 23 over here to over here. So they are separate copies of 23 because they're primitive. On the other hand, if you got reference type, right? Let me just say it again, okay? If for this particular attribute is pointing to some objects rather than primitive, in that case, a shallow copy will let it point to the same objects, right? That's a difference. Okay, we have seen 1, 2, and 3. Why don't we see more? Okay, number 4. Oh, sorry, didn't see you. Yes.
Because so essentially an even integer, right?
Correct.
So no reference copy. We create a new variable ID in the new object.
Yeah, correct. Because ID is of type integer, like a primitive type, right? So in that case, we don't have any notion of address. So you just copy the value. That's correct. There's no aliasing issue here. All right, let's see number 4. Okay, number 4 over here, let's take a look again. So hopefully now you have a little bit more ground to judge. O keyword over here, so now tell me what would be the expression to be cached in the pre-states? Accounts? Would you agree? And you really have to watch out for parentheses, which means when you are writing your contract, you may have to use parentheses when necessary. In this case, you can see parentheses is basically here. So that means old keyword only applies to this particular account, only that. Okay? So now, what will be the caching? Okay? Number 4 will just be assigned to just accounts. In that case, we are making a reference copy, agree? Of the array, right? In that case, number 4, I'll put it here. Number 4 is now just pointing to this particular array. You can see we're talking about the same runtime structure for the bank, but now depending on exactly how you write a post condition using the old reference copy, shallow copy, or deep copy, the consequence will be different, right? Depending on which one you have chosen. Let's look at another one. How about this guy here, number 5? What exactly are we caching? Number 5. Oh, in case you cannot see the number. Sorry about that. Number 5, the orange. Do we cache the account objects? Do we cache the integer ID? Do we cache the accounts array? Be precise.
I think because we want to cache the accounts, but we're going to make a shallow copy. It's not a reference to account, but make a new
That's exactly right. That's exactly right. Very good. Okay. Again, parenthesis is very important over here. So old keyword applies to this particular expression, right? So now under the hood, we should have an implicit assignment in the pre-state like this. Number 5 is simply assigned to accounts dot twin. So now we have seen this already from the example last time. How do we visualize that? So now, number 5. So now what should I do? Should I create a new bank objects? Should I create a new account objects? Accounts. Should I create a new account object? Are you sure?
You should just copy all of the addresses.
Of the array. But should I create a new array to begin with?
Yeah.
I should. Yeah. Maybe missed that part. Okay, good. Basically, number 5 is now going to point to an array just of the same size. Okay. And then somewhere we got index I. So now index I is just going to point to the same array, just the same. Okay. That's a shallow copy. So the shallow copy of the array. And we did talk about how you can make a shallow copy of an array of string, right? Shallow copy of an array of counts, just the same principle. Okay, why don't we, for the sake of completeness, why don't we try to complete the other two, okay? Number 6. Do you think number 6 will be cheap or expensive? Oh, by the way, what's current, in case you don't know? Current simply means this, okay, if in case you need that analogy, okay? Whenever you talk about this in Java, the current object, current is exactly the equivalence, okay? So now the O keyword is applying to current. And what's current? The bank, right? We talk about in the context of the bank. So now, in this case, what we will do is number 6 will just be assigned to just the current bank objects, okay? So that means number 6, if I put it here, is now just going to point to just this bank, the current bank. Jordan, question.
Would the compiler ever recognize that, like, since current isn't going to change, that like it doesn't need to cache that value? Or?
Actually, current might change sometimes depending on,
Really?
yeah. For example, let's say if current, well, for example, just for example, let's say if the current is simple, let's say the current, just the current object we're talking about, is simply pointing to some binary search tree, for example, right? Let's say I'm trying to say rotate my binary tree somehow. I want to make sure I'm only affecting maybe one part of my binary search tree. On the other hand, the rest must be the same, right? So in this case, if I'm only making a reference copy of the current as the old current, would that be good enough? The answer is, I'll tell you, the answer is no. Because current and old current, in this case, they're reference copy of each other. In that case, making any changes, the two references are still pointing to the same object, so you cannot tell the difference. In this case, you might need current a deep twin. In the sense that, before I try to, okay, let me be a little bit complete on this example here. Let's say this. Let's say this is my current binary search tree. Before I try to apply some changes, what I would do is I would say old current deep twin over here, just some variable. That one is just going to be a complete independent copy of that. So now, when I try to do changes on the current object, I'll just do it over here. Let's say this part has been changed. So now, as a post condition, what am I supposed to do? What I'm supposed to do is I want to compare this copy here versus this copy and make sure whatever change I can observe from over here, from there, is what I expected. Yeah.
Sorry, just to clarify.
Yeah.
If we had a full pointer to this, and like you're saying that within a method that was called on this, that the value of this will change?
It depends on how exactly your method is going to update the current objects. Okay. Yeah, let's bear with me a little bit. So far, we're still discussing at the syntax for the syntax level. We're going to see some complete example. You can ask me again. Okay, question. Current refers to the context objects. So like this. For example, let's say when we talk about binary search tree, right? If you say I have an object of type binary search tree called BST, for example, when I say bst.insert something, so BST is the current right now. Okay, just the this, right? No problem. Okay, good. Okay, guys, let's do one more. Just do one more. Number 7 over here. Number 7, we also got O keyword. Again, we got parentheses, right? In that case, what should we do? That means we are trying to cache current.twin. So that means we're making a shallow copy of the bank, right? In that case, how are we supposed to draw it? So now in that case, that means number 7, somewhere hidden, is simply assigned to current.twin. So now that means we're making a shallow copy of the bank. Okay? To make a shallow copy, let me draw it here. That means number 7 is now going to point to a new bank object. Let me draw the bank object first. And as we know, bank object got something called accounts. Okay? Now, should we create a new array? No, for shallow copy we don't have to. So I'll try to avoid conflict. So now that means this should point to this particular array, like that. Okay. Basically, the point about this whole illustration here is, depending on how you write an old keyword, how you parenthesize that, and how you combine that with a twin or deep twin, you can have different consequences. And we're going to see exactly why some of them might be appropriate, some of them may not be. We're going to see the complete example in just a moment. Okay, any questions? Yes?
So sometimes for all expression we both can stick to it, you don't have to stick to it, depending on the...
I think depends, yes. If there are certain assumptions you can make about a supplier, to say maybe the supplier will never try to make some deeper changes, if you can make that assumption, maybe deep twin is not necessary. But if you cannot make that assumption, you better use deep twin, right?
I know it's maybe not exactly the proper question now, but is it possible to kind of start to look a little bit about the project and about having partners, like just kind of brief overview so we know like can start like thinking about our project?
Are you talking about the semester, the end of semester projects? It may be too complicated to talk about project right now, but don't worry, it will come, right? I think you try to spend good efforts on lab number 3. Lab number 3 is going to introduce you to a framework that's going to be reused for lab number 4 and lab, also the project. Well, we'll talk about it, yeah.
We can have 2 partners or maximum, right? It's on the website.
So I believe, yeah, I think each team can be maximum 2 members, okay, either 1 or 2. But I can definitely find your partner from other section. That's fine. Okay, I will talk about the issues about project later. Okay, good. That's about the. Okay, let's now move on. Okay, if everybody is okay with this. Okay. Again, you don't have to do this kind of caching process yourself, but you have to know how it works at runtime. Okay, we have covered every possible expression over here, and notice one thing here. I did not give you any example about deep twin, but you can hopefully infer that, right? The same idea. But now we're going to see another example to use it. That'll be the ultimate example we want to master. Okay, so now when are the contracts complete, right? So now we want to talk about how to write complete contracts. And in order to really do post condition, we have to draw the relation between pre-state and post-states, right? And now, so we're going to talk about different variables. They might be composite type or maybe simple type. Okay, if your attribute or variable are simply composite type, like an array, linked list, or graph, in that case, you have to be very careful about what should be changed and what should be unchanged. That's why you need some old keyword over there to help you, and possibly with deep twin. And if you're lucky, just integer Boolean, you don't need to worry about this thing too much, right? But for a realistic project, you definitely have to worry about composite structure, data structure. What's the rule of the thumb? Every time if you want to change some collection type objects, 2 things you got to write about it, at least. Number 1, you want to make sure the intended change is present. For example, remember the array example we talked about? If you want to modify just position I is what you intend to change. But the rest of the array, from 1 to I minus 1, from I plus 1 to count, they should remain unchanged. That's one example. Okay? Think about what should be changed, and the rest of the structure is unchanged. That's the tricky part to write. So you need some kind of logic to express that. But we'll talk about it today, for sure. It's hard to specify. Number 1, you got reference aliasing. You want to make sure the copy you make about the old expression in the pre-states is not such that they got aliasing, so the changes you're trying to make is invisible, right? That's kind of the example we talked about last time. Okay, but we're going to see that again. So you have to decide reference copy, shallow copy, or deep copy. I would say most of the time, if you simply use deep copy, It's not gonna hurt. It's just slow. But for your understanding, you should really know why you should use shallow copy when deep copy may not be necessary. It depends. Okay. Okay, also iterable structure. We're going to talk about it. We're going to use it across as well. Okay, so now we're going to talk about a new example. Okay, we're going to use, again, we're going to use bank and account. Okay, and this basically continues with our example that's used in the first class when we talk about bank and account. Right. So let's just go over the classes very quickly. There's a little bit more exercises we can do quickly as well to write contracts. Let's say we have a class called account. Okay, very easy class. Let's say it simply inherits from any class like objects, and then you got to really find is equal for object equality to compare their contents. Let's also we got a constructor called make, and then let's say for every account you got owner, you got balance. Okay, string owner and also integer balance for every account. And then for the constructor command, you just initialize the owner and also balance to be 0. Easy. Okay. And then let's say we have a deposit command, in which case we simply just try to increment the balance. Of course, you can definitely put the precondition to say A over here should be, for example, positive. You can definitely do that. But for now, let's just omit it for simplicity. And then also we got is equal here, right? You have seen this for your lab 1. Okay. For two accounts to be equal, owner and balance must be equal. Okay. That's the account class. Easy. Okay. Let's go to the bank class, and then we'll be ready to write some contracts. Let's say we got bank class, and then we got accounts of type array of accounts. And then when you first create the bank objects, simply initialize the array to be empty. Okay. Now, this feature is very critical. I want to make sure you're comfortable with this before we can continue. Okay. This feature is like an accessor. It's more like a query. Given a particular owner name, you want to see if this particular owner already exists in the bank. If they exist, return the corresponding account objects. Okay? Let me draw a picture very quickly. This feature is very critical in order to write contracts, so I want to be careful here. Account of. Okay? Let's say this. Let's say for our array of accounts, let's say over here. Let's say accounts over here is simply got, let's say, only 2 accounts over there. Okay, just for this particular example, we're gonna try array of lower index 0. Just try different variety. Okay, just 0 and 1. Just back to what you're used to. And then let's say the first account over here is just account. We got owner, we got balance. Okay, the second one is like this. Okay, ACC, and then we got owner and also we got balance. Okay, let's say the first one, the owner is simply just Alan, for example. And the second one is simply Mark, and with some balance. Balance is not important here. Okay, let's say we got that structure here. That's for the bank. So now, if we got a particular bank, objects, dot account of. How do we use that particular query? If I say bank.account of, if I simply put, for example, Mark, okay, I pass a string. So now the precondition should be whatever owner name you pass must exist in that particular bank account setup. Okay, in that case, in that Mark does exist, it will match this particular account object. So what we return is this particular object. Basically, this will be the return value. Return this particular object, its address, basically. Okay. On the other hand, if I try over here, if I try bank dot account of, and then if I try Alan over here, quite obvious, return this object instead. You return account objects. Okay, is it clear what it's supposed to do? Okay. This is really critical. We're going to need that in order to do postcondition later. Let me go back to the slides quickly. Okay, so now, question for you. How do I write a precondition to make sure, for example, if the clients try to call this particular feature using, for example, like this. If they try bank dot account of Tom. Apparently, Tom doesn't exist in the current bank. In that case, you shouldn't really just go ahead and search for that and waste your computing power. What you should do instead is to blame the customer. blame the clients for not really satisfying the precondition. So now, how can we write this precondition to say, if you want to get an account of someone better exists in the bank? How do we do that? Guys, any idea? How to write the contracts? Using a loop? So you got, okay, let's say the precondition. Now we want to talk about how you write a require for account of. Account of simply, let me be consistent with the signature. Okay, account of will simply take some name of type string. Okay, so now how do we write a require? You're saying use a loop. What kind of loop? Across or from until loop? Across? Okay. By the way, can you use from until loop over here? Can you? No, you cannot. It's simply not going to compile. Okay, it's a very common mistake. Okay, if you simply from until something over here, okay, it's not even going to compile simply because under this particular precondition or for any contract, the pre-post condition and class invariance, you're supposed to specify a Boolean expression over here. From until loop is not a Boolean expression. It's simply some instruction to do something. It's not Boolean. Okay? So this is not going to compile. Just remember that. And don't write this in the lab test. Right? It's not going to compile. Okay? The from until loop does not return a Boolean value. That's why you cannot use it in the context of contracts. Yes, correct. Jordan.
Sorry, I'm still hung up on the earlier thing. So you see how you have bank.account of Mark and bank.account of Alan?
Uh-huh.
So suppose those were executed in order, right?
Mm-hmm.
Suppose bank account of was written so that, because I'm still supposing your earlier example,
Uh-huh.
you were saying that the address of current could change, right? So are you saying that the value of, like the address of bank from the first method would change by the second method? Like potentially?
Oh, okay.
So like, because if you're saying old current could be different from current at the end of the method, then what that would mean is that bank could have a different value by the time you call the second method.
I see what you mean. Yeah, your question was, okay, in general, if I try to say bank, for example, bank dot some method or feature over here, right? You're basically asking, if before the feature call, bank was actually pointing to this particular feature over here, is it possible that immediately after this particular feature, bank is actually reassigned to another object? That's what you're asking, right? Okay, the answer is no, it's not possible. Okay, first of all, okay? The reason is very simple, okay? It's a very important programming question for you, okay?
But that's why I'm saying I don't understand how current could change. If that's
The current wouldn't change, actually. The current wouldn't change per se. The reason I show the example there just for completeness, just to show you might write old current, but it may not help too much, right? You might write it. Yeah, okay. The reason that is this. Under any method, let's say you got a class over here. Okay, let's talk about Java, right? It's the same idea. If you got a class called foo over here, and then if you got some method over here, can you actually write this is assigned to something, right? The answer is you cannot. You just cannot reassign the current object to something else. You just cannot do it. Okay? So the same idea. So now in Ifill, you also cannot write current is assigned to something. Well, both are simply disallowed at the compiler level. Okay. Okay, so now let's go back here. Yeah, question.
So when you write bank account of, right, it returns an account object or it returns a reference to an account object?
Okay, to be more precise, when you say bank that account of, okay. Well, basically, think of this. When you look at the return type, it's account, right? Agree? Well, it's actually true for every OOP language. When you see the class name as a return type, that means you're returning a reference for an object. It's always indirect, always. Okay? All right, good. Okay, so now let's think about how we can write this particular contract very quickly, okay? I think that's something you would need, possibly for your lab test, I guess. Require. So we just learned that using a from until loop here is not good because that one does not return a Boolean. Never do that. Okay. Now, what should I write for across? I got three options there, right? I can say across loop. I can say across all. I can say across sum. Can I say across loop? No. Using across loop is just like using front until here. It's not going to return a Boolean, first of all. Okay, let's understand that. Okay, now to either use across sum or across all, either way works because they're logically equivalent. Okay, but now I want to say this name I'm trying to look for to return the reference of. The owner name better exist. It should be either Alan or it should be Mark, for example, in this case. But how can I write that? Which might be more convenient to write? Should I use across sum or across all? Well, think a little bit more. If you're not too comfortable with Ifill, that's okay. Think about logic. Does it make sense to say for all or exist? I want to know whether the name over here exists in the array. Well, that's quite obvious, right? So shouldn't you use there exist? Okay, so now let's see how to use it. So now you can say across, for example, across the accounts array over here. Okay, and now you can say is. Let's say ACC. So now after this, what would be the type for the dummy variable ACC? Account, right? Account is simply an array of accounts. So every element there is an account. So now let's use sum, for example. Okay, what should I write over here? Anybody help me out? Should I say, for example, ACC tilde n? N is this parameter here. Would that be right? First of all, why is that wrong? Anybody can point it out to me.
ACC is an object, like it's a type of count, and it's
Very good, very good. Okay, first of all, this will compile. Compilation is not a problem. That's why I want to point it out to you. That's another kind of common error you might make, which might take ages to debug. Every time you use tilde, there's a catch. Whatever you put on the left-hand side and whatever you put on the right-hand side, the type doesn't matter. It will always compile, which means if I simply write something, I believe that's also fine. If I say 2 tilde 3, because this is more like an object, well, like an expanded type. Well, everything is an object in Ifill. This is just another kind of object. So tilde is fine. Okay. So now this guy here is not good. So what we should do instead is say acc.owner tilde n. That's the right way to put it. Okay. I just want to point out to you because if you wrote simply acc tilde n in the lab test, nobody would, the compiler is not going to complain, but it's just wrong. Okay, just be careful. Okay. Yes. Sorry, say it again. Sorry. Oh, y.owner? Okay, well, it's easy. Thinking this way, you're basically comparing apple with orange, right? Well, if that makes sense. If you say, what's the type of ACC? Yeah, that's accounts. You're saying that it's tilde, let's say n. What's the type of n? String. Yeah, you're comparing two different things. How can you compare them, right? So that's why you should say acc.owner. Yeah, basically it's going to go across this particular array, and for every account you're looking over, want to make sure the name over here, some of them, actually matches the name you're looking for, so that you can return the address of this particular account object, right?
So the way that owner looks at the n is a string, so looks for a string in the count and check those.
Correct, correct. That's correct. Okay. Any question about this?
What's the difference between the is and as?
Is and as, okay, I would suggest the following. The question was, what's the difference between is and as? Anybody who can help me out? Yes.
So, is can be maybe as can be the person.
Yes, correct. Okay. If you say as, whatever that goes after, if I say as ACC, in this case, ACC is no longer just an account. It's going to be a cursor to an account. In which case, you had to say acc.item in your across loop. In order to clarify this, I would suggest look at the in-lab demo from Friday. I did illustrate this. Please take a look. If you got trouble, come back to me again. Okay? Again, when you use a cross loop, you can either say across S or across is. I don't care which one you use. Just be careful, right?
Just make sure that if we use as, we write acc.item dot owner or acc.
Good question. Why don't I write it? The question was, if I want to write across S, no problem. How exactly do I write it? Goes like this. Across accounts S ACC, okay? And then I can say sum. Now, if I simply say ACC, I'll give you the wrong version first. Okay? If you say ACC.owner, tell that N, for example. This is not going to compile. It's going to complain that owner is not defined as an attribute for cursor. All right? So what you should do instead is to say, this is wrong, acc.item is now going to give you the owner. Okay? Sorry, it's going to give you the account. acc.item and then .owner. Since I already talked about this, think about this is more like accounts. If this is the accounts, all right? And now we might get different account objects over here, okay, like that. Okay. When you say S, you can think about ACC is more like pointing to a cursor objects rather than pointing directly to some account objects. So now ACC itself has a field called item. Item itself points to some account object. That's why there's one level of indirection you have to be aware of. Make sense to you? Okay. Question? When is it useful to use S? To be honest with you, the is keyword was only introduced in the last version of Ifill Studio. I think they might find that S is too confusing to the user. That's why. Okay, so I would say for the lab test, doesn't matter which one you use as long as it compiles. In the exam, if somehow you use the S but you forgot to put the item, that's okay for the exam. Okay, but for the lab test, you gotta be careful. Okay, so now that's about the account of. Let's go back here. Okay, that's the answer. Okay. Oh, I just put another version there in the comments to say how you can rewrite it in a way that's using for all. Okay, take a look and convince yourself that's right. Okay, you can use either one. They're logically equivalent. Okay, and then, so now account of, the implementation should be quite obvious. That's why I didn't put it. Okay, just go over the accounts and then return the object when necessary. Okay, for that one, I'll leave it to you. And we got another one that's called add. We want to add a new account into the bank with owner N. So now we want to make sure it's kind of the opposite, right? If you want to return the account of, the name better exist. But now, if you want to add a new account, the name better not exist. Agree? Okay, good. Well, you can just look at that. Okay, just make sure they're the logical negation of each other. Just case studies for you. Okay, add would be very easy. You just force into the array. We'll talk about force already. Okay, guys, any question about the two classes, right? If you look at, let me just take a look quickly. These are the two classes we talk about. I would say the most important class to most important feature is the account of. We're going to use that a lot in the post condition. Questions?
You made a video series back in 2015 for Ifill, sound by country about the bank and accounts and stuff. I told at the beginning when you don't get confused, Ifill use that to understand. Do you think it's useful to finish it all to better understand what you teach now as well?
So the question was, should you watch the tutorial for the bank account? I would say, yeah, sure. You should really watch them. Yeah. Would it be confusing? I don't think so. I recorded that, so it cannot be confusing, right? Yeah. It's not too late yet, I can tell you. It's never too late. You better watch it. Yeah. All right. Let's now talk about some interesting stuff, okay? Now you got everything ready, everything you know about. Oh, question. Okay, say it again, sorry. It's a very good question. Let me just go there directly. It's a very good question. I'll repeat the question in just a moment. Okay. Okay, the guys, Ring's question was as follows. Let's take a look at, let's say the add, for example. No, maybe not add. Let's say account of. Account of over here, what Ring was suggesting was this. Rather than having this, can I simply do the following? I say accounts dot has. That's what you're suggesting, maybe? Okay, good. I understood you correctly. Would it be okay?
No, because n is not of type count.
Yeah, exactly. It's not going to compile. Okay, but I want to point it out because you might think it's doable. Accounts over here is simply an array of accounts. Name over here is simply a string. You can see the string doesn't match the element type account, right? So it's not going to compile. That's why I got to use a cross loop. Yeah, just be careful. Yeah. Okay, good. Let's go. Let me go back here. So now let's talk about what we're going to do. We're going to consider a particular feature in the bank. It's going to be called deposit on, which will take two input parameters. The first input parameter, we're going to say, given the name of some owner, if the owner exists, we're going to deposit some amount A into their account. Is it clear? Okay, at the bank level. Of course, there might be a precondition there saying that the name N must be some owner name. Well, we know how to do it already. Okay, that's the feature. So now, let's now think about, the precondition is pretty easy. Think about how we can write complete postcondition to it. For example, if I want to deposit onto Steve's account, I want to make sure I only do it to Steve. I don't do it to, for example, Bill or others in the bank. That's kind of the thing we want to write. But we're going to see how we can do it in a general way. In order for you to learn about the wrong versions and also the correct versions, I think it's always important to see the wrong version first so we appreciate why the right version is good, right? We're going to see 5 versions in total today, hopefully, okay? 5 versions. The first version, let's say the contract is simply not complete. However, we're lucky because the implementation just happened to be correct. So we are not having a crazy supplier. So that version 1 is kind of lucky, but you cannot rely on that. Version number 2, contract is still incomplete, but now the supplier is evil. They did something very wrong. However, the incomplete contract cannot catch it. So there's something wrong. Okay? From version 1 and version 2, we'll see what the problem is. So we better try to write complete contracts. From version 3 to version 5, we'll make an attempt to write complete contracts. In version number 3, we try to use complete, but we use a reference copy of the pre-states. We'll see how useless it might be. Well, you got to see that, right? Version number 4, we're going to use a shallow copy. And shallow copy, we know that in some cases, it might be okay to see the changes as we learned from Monday. But in some cases, when the change is made beyond the first level, it cannot work, right? So version 4 is still not satisfactory in general. That's why eventually we should go to version number 5. We have got the complete contract using deep copy for the old keyword. That's something we're going to go through. Okay? All right, let's see how much we can go. Okay. Before I do that, okay, let me just do one compilation error very quickly together with you, very quick, just in case I cannot get there. So this might be useful for you to figuring out some compilation error, not just for lab 1, but later as well. Okay, let me do this one first, and then I'll go to the 5 versions. For now, could you please take a look at this particular class, slightly different class, okay? Sorry for the diversion, but I think let's sort it out first. I'll go over the class together with you. Let's say we have a class called linear container, let's say, okay? A different class for a different issue. And then we have a constructor called make. We got a array of string. We got count for the size of the linear container. Also, we got get. Get is going to say whatever valid index it is, we want to get that particular element in the linear container, right? Just I. Let's assume that I is simply valid. Let's assume, okay? And now let's take a look at the update command over here. And then it's going to take I. It's going to take some new element V. Basically, the idea will be now, well, basically you have seen this already. If this is linear container, at position I, we want to change that. Used to be maybe here. Rather than this, it's now going to change to maybe V. That's kind of the intention, right? Very easy update method or feature. Now, This is some error you might have run into already for lab 1. So that's why I want to talk about it. Take a look at this particular across. Okay, first of all, take a look at this across loop. It's in a post condition. That is why we can use O keyword. Okay? Can you tell me if there's anything wrong with this particular cross loop? Hold it. I will see if anybody wants to have a say. Does it even compile? Well, if I ask you this way, that means it's not compiling, right? So now, why would it not compile? Can anybody tell me? You first. There's no old version of J. That's pretty much correct. Okay? So now, given what you have learned so far today, let's be reasonable here. Okay? First of all, the conclusion is this particular cross loop is not going to compile. No, negative. Right? Let's see why. First of all, you can see the O keyword is exactly over here, right? Which expression does it apply to? Get j.item, right? This is the one. That means in the pre-states, okay, think about right before we try to execute the implementation for this particular updates, we try to do some caching, right? What will be the caching? Let me write it down here. The caching would be something like some cache variable CCV, right? It's assigned to get j.item. Now, Ifill will have some trouble doing this because does j even exist in the pre-states? No, it doesn't exist. Where does j exist? J only exists when you actually get to the post states and run this particular cross loop. J only exists over here. J only exists in the post states. And when you are trying to do this over here, it's a compilation error because J does not exist in the pre-states. Some of you already showed me your code during the lab session or office hour. That's exactly this issue over here. I want to explain that to make sure everybody's okay. Right? By applying what we learned in the beginning of today, so now this should make sense. Are we okay with this? Okay. Understanding there's a problem is important, but you still wanted to make it compile, right? Otherwise it gets 0 for lab test. How do we fix it? Brackets is good, right? How do we bracket that? One possibility would be, can I bracket this way to say old get, well, I don't know, j.item. Can I do that? Are you sure I can write something like that? No. It's not even syntactically correct, right? Okay, write it. Current is your friend in this case. First of all, this is not good. Okay, don't even try that. So now the way to do it would be to fix it. And now I can say old current, the current object for linear container, and then dot get j.item. Now it will be okay because what will be cached right now is the current object over here. However, depending on exactly what you want to really prevent from happening, you might find that later after we discuss the 5 versions. Maybe it would be better to write, rather than old current, you may want to write old current dot dtwin. This might occur to be useful at sometimes, which means rather than just making a reference copy of the current object, as we discussed, current object never changes its reference, but its context might be changed. In that case, if you say old current.dptwin, in this case, and then dot get, and then j.item, this is actually might be occurring to be useful sometimes. Okay, just remember that. Okay, any question about this? It's a discussion I would like to have first before we dive into the 5 versions. We okay? All right. Okay. Yes.
So this version, old current brackets dot get j item is correct, right?
Which one? Okay, first of all, this version here, at least it compiles, but may not be very useful because you're just making the current, like a reference copy of the current objects, right? That means any changes you make to the current objects cannot be visible, right? So this version is better to say old current deep twin, which means making a deep copy for you to compare, the contents, any changes you may have made.
Doesn't that become ultra expensive though?
It is true, it is expensive, but remember the purpose of doing decide by contract is by guiding your developments, as we said before. Eventually, once you reach the equilibrium or stable point for your contracts, you can turn them off, right? But for now, we're trading efficiency for correctness, basically. Yeah, just remember the rationale why we're doing this. You're absolutely correct. If you just do old, current deep twin over here is very expensive if current is a large bank or large tree, of course. But that can help you check supplier errors, which is beneficial. Okay, so now let me roll back a little bit. Okay, now let's talk about 5 different versions. Okay, so now let's switch back the context to the bank. Okay, and we're going to talk about different versions, and let's assume the following bank data structure. Just make it simple, but we're going to make right to the point. Let's say we have a bank called B, and the bank has accounts, let's say of size 2. Indices start with 0, just as a try, for a different variety. And then let's say the first account is Bill, and the second account is Steve. Only 2 accounts. Okay, make it easy. Okay. And basically, what we want to do is something like this. We're going to see 5 different versions of writing the post condition, right? And then for all the 5 versions, we're going to run some similar test to test the correctness. Let me just show you the test very quickly. That could be also a nice case study for e-spec test. Okay, we create a new bank, and then we add Bill, add Steve. So Bill is the first account, Steve's the second account, and then we try to say B dot deposit on V1 is version 1. We got 5 different versions, and the source code is available to you. You can also play with them. Okay, and now if you want to deposit onto Steve's account with 100. Okay, after this, what we really want to make sure is, now, if I say B.account of, right, we're using account of, what should be the balance for Steve? Should be 100, from 0 to 100. But it's also important, the balance for Bill, all the rest, should be remaining 0. That's kind of the correctness criteria we have for that particular feature. Okay? We're going to see the same test for all the 5 versions. Okay? Let's now go on to talk about the 5 versions. Let's start from version 1. Deposit on. Okay? Now we're in the context of bank class. Deposit on, let's say some owner name, some amount. Okay? The precondition, you can write it. Okay? Simple. We talked about it already. And this loop, you can assume it is simply just correct. Basically, we're running a from until loop. We're saying going from the lower until the upper. And then, if we can find out the current account we are looking at, the owner is the same as the owner name we're looking for, then you simply deposit on that particular account, and that's it. Okay? And we are lucky, in version 1, the supplier is doing the right thing. So in some way, it doesn't quite matter if the contract is weak or strong. It doesn't quite matter. But you cannot rely on that in general. But just for version 1. For version 1, you can see the number of account unchanged. We simply say accounts to account. Well, just the size is the same, right? And number 2, we simply say, now, can you take a look to see what it is trying to say? Take a look. The second one, balance of N increased. Apparently, we're trying to make 2 calls to account of, right? What are we doing exactly? In some way, this is a little bit more like the withdrawal post condition that we talked about in the beginning of the semester. This one is slightly more complicated because now we are in the context of not a single account, but a bank. Okay? And why are we calling, for example, account of twice? And apparently for the second call to the account of, we're using old. What are we saying here? even version 1 takes a little bit of understanding here. Okay, let's go slowly on this. Okay, let's see how many versions we can do. Okay, let's say, oh, sorry, iPad is here. All right, the same code over here. Okay, like that. Okay. Okay, this guy here is pretty easy. Let's not worry about it. That one's easy. Just make sure that the size of the accounts doesn't change. Okay. Let's take a look at the second one. Let me make it larger for you. If you look at that, can you tell me exactly what value is going to be cached in the pre-states? Are we going to cache an integer? Or are we going to cache a string? Or are we going to cache an account? Or are we going to cache a bank? Integer. Okay, that's a good sign. Okay, let's see why. Okay, it's really important. That's why I talk about all the example in the beginning, right? Because now you got to judge. The old keyword is over here. The longest unbreakable expression is exactly over here. That means we're going to make a feature call exactly this verbatim in the pre-states and store that in some temporary variable under the hood. And then when we get to the post states, we're going to compare this particular left-hand side with this particular cache variable. That's what's going to happen. But let's see exactly how this is going to happen. Okay? Let's see this. Let me clean this a little bit for you. Okay? Just make it more readable. Now, I want you to pay attention to the following. Okay? This is the expression that we're going to cache. Okay? So now, let's say we already passed the precondition, let's say. And then the end, let's talk about this particular feature call, Steve and 100. So this is Steve, and this is 100. Okay? And we already passed the precondition, so now, right before the body of implementation is executed, we have to cache the value for the post states, right? For the post condition. Okay? So now what should we cache over here? So now over here, let me just call it O variable. Let's say old balance over here. It's assigned to this particular expression verbatim. Okay? So now it's going to be, I'll just write it down. It's going to be current dot account of. And then whatever name it is, in this case it will be Steve. And then dot balance. Notice that plus A is not part of it. It's not, right? Because you already got a space, right? Okay, so now this is the value we're going to cache. What will be this value in the pre-states? 0? Good. Because now Steve is this particular account, the balance will be 0. So that means old version of the balance will be 0. And this is already cached there. We're going to use it later. Okay? So now if we try to execute the body of the implementation over here, it's going to do the right thing. It's going to deposit 100 into Steve, right? So that means for Steve, it's now going to be 100. And question for you. When I was trying to modify this particular attributes, am I modifying this particular variable at the same time? I'm not, because they're separate copy. That's the beauty about using the old expression properly. Okay? So now, finally, when we try to evaluate this particular Boolean expression, how do we evaluate that? Okay? How about this? When I say current account of and the balance, what would that be? 100? Agree? Because now current is basically talking about the modified version of the bank, which is now pointing to this particular modified account, right? Account of Steve, oh, this is Steve, of course, assuming that account of, you know how that works. And then, in that case, for this particular expression over here, it's just, the green one is just going to be 100. And we're saying that 100 equals, and now this cache value, we can now just use it, right? It's being cached from the pre-states, equals 0 plus 100. Would you agree this is just true? That's how the post condition works. This post condition is not too bad, just incomplete, because it only worries about the account that's being deposited on. What about other accounts? It doesn't say too much about the rest of the bank. That's a problem. Okay, let's see exactly how to reveal this problem. Okay, I'm paused a little bit. Any question about version 1? I think even for version 1, you want to be very comfortable with when I actually write expression like this for the old keyword, what does it really mean, right? Make sure you understand that. Yeah, question? Correct. So under require, under ensure, and under invariance, they should always be Boolean expression. That means from until or cross loop. They shouldn't be there, right? It's a no-no. Okay. Good. Okay, let's talk about version 2. Okay, for version 2, we basically want to say in version 1, you're simply just lucky. Your supplier is not insane. But now let's talk about version 2. For version, if you run a test, you're going to see everything seems to be just fine. But just being too lucky. Version number 2. Basically, let's assume we got a from until loop. That's correct implementation. But now we're going to inject some wrong line of implementation. Let's say this crazy supplier, every time after the correct implementation from version 1, they will simply say, I'm also going to deposit onto the first account of the bank this equal amount. That's basically wrong, right? If you only want to deposit into Steve, you will also deposit into Bill. Apparently that's wrong, okay? So that's the only change we are making in this version here. So now what about here? The same contracts. Do you think this is going to be fine? Well, if I run this feature here, am I going to run into any post condition? If I'm not going to run into any post condition, but there's something wrong, that's bad. Contract is supposed to catch something when something goes wrong. Okay? So that's not good. Okay? Let's explain that very quickly. Okay? Basically, if you think about it, okay. Again, this particular old expression here is just going to cache, right? And it's going to cache simply just n over here. Again, we talk about b.deposit Steve. And then we got 100 over here. Okay? So this particular expression is simply just going to be for Steve account in the pre-state, which will be 0. All right? And then now in the body of implementation over here, not only that we're going to deposit into Steve 100, but also we're going to say deposit into the first account the same amount. So also do 100 over here. So now, is the current post condition able to catch this bug here? Is it able to? Not able to. Simply because if you look at that, this post condition here only concerns about owner n. In this case, only worry about Steve. But for the rest of the bank account, it simply doesn't care. It doesn't check. Not having checked it doesn't really mean it's not a problem. So version 2 is not good. Okay? Version 2 is telling you when you have incomplete contracts, that will just give you some false hope. Right? You thought that your software is okay because there's no post condition, just because your post condition is too weak. It's not complete. Okay? So now, what we want to do is to think about how we can write a complete contract using maybe to worry about the rest of the array. And for this one, I would like to draw your attention to how to write it. Okay? I may not be able to finish everything. I only got about 7 minutes. I'll try to give you the most, okay, before the 7 minutes up. But we're going to finish the rest next time. Okay? Let's see this. Think about how we may write this particular post condition. If the accounts array is now pointing to, just in general, in this array of accounts, and let's say you might get more accounts over here, okay? Let's say for this particular accounts, ACCOUNT, and then the owner is simply just n. Let's say that's the account we would like to deposit into, right? And then the balance may be 100, for example. Doesn't matter. Just something here. The idea would be we only want to modify this particular account, let's say. So the feature we're talking about is b.deposit on. Deposit onto n, maybe with $50, for example, let's say. Okay? And now we want to make sure the rest of the account, I'm going to color them as maybe green. This part here and this part here, the owners are simply not n. They should remain the same, basically, right? That's what we want to specify. But now, let's talk about how do we specify that logically. How do we do that? Given what we have got. Okay? You know, I'll slow down a little bit. Okay? I think working out this logic is really important. How do we specify the following? All accounts except the one with owner n have remained the same. Okay, let me just point somebody, maybe from the back, if you haven't got a chance to speak up yet. Yes, please. I agree with you. We can use a quantifier, and then would you suggest we use exist or for all? Okay, seems to be a good choice. Why don't we try that first? Okay. Now, we can definitely use a quantifier. That's true, because we want to say for the rest of the account, except for this one, they don't change, right? What should you cross over? Across over the accounts or across over the indices? You got to make some decision. In the slides, I actually gave you the solution using across the accounts. Okay, but now I'll give you that version first, and then we can talk about maybe on Monday how to write alternatively. Okay, I will start you with this. Okay, the final solution we will get is something like this. Okay, across old accounts dot deep twin. This is the final version, but I just want to tell you now because we only got about 3 minutes. I'll give you a little bit of hints. Okay, accounts dot deep twin is ACC or N over here. Okay. Think about what we are caching here. We're saying that before you try to execute the implementation for account for deposit on, make a deep copy of the entire array and accounts so that we can compare one by one. Okay? So you might find this particular pattern useful maybe for your lab 1. You might find that. Okay? I'm just telling you first, right? But we'll explain a little bit more details on Monday. Okay? Now, what should I put in the all in here? I'm basically crossing over the old version of the accounts. I want to say for every account I'm looking over, if the owner of the current account is the same as N, it has to be changed, right? But if it is not N, it should not be changed. Okay? So, yes, you want to say something? Yeah. Implication? Yeah. Right? Good. Why don't I write it down first? Give me 2 minutes. Okay? Well, let's finish this. Okay? So what I can do now is I can say ACC, which is account, dot owner, if it is not the same as N, which means they are not supposed to be touched, right? That implies. Now I need your help on this. What should I say here? Implies what? Yeah, basically you want to say this particular account, given that it's not the one to be changed, it should remain the same, which means its old version should be the same as the new version, right? Saying the old version is easy, I can just say ACC. Because ACC was a crossover old version of the accounts at Deep Twin. So now, how do I say the new version of this particular ACC? Huh? Is there an auxiliary feature I can call? Current dot account of. Okay, good. I'll put it here. Current dot account of, and then N. Oh, sorry. And then, sorry, I'm running out of space. Over here, you just say ACC dot owner. I'm saying that for this particular account, if its owner is not N, which means I don't want to change it, then its old version and the new version should be the same. Okay, I'm just trying to work out the logic with you. Yeah, question. Oh, why should it be a deep twin? Okay. Yeah, we are really running out of time, but I'm just saying, it turns out you should really just put a deep twin over here to make sure if there's any changes made to the current objects, you can still see it in the old version. Just take it for granted now. We're going to explain in detail on Monday. Okay, I'll see you on Monday.